Hello friends, this video on light, reflection and refraction part 15 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 14 before going ahead with part 15. So with this, we understood what is refraction of light, right? So now we will see how does refraction takes place by lenses, right? Like how we studied the reflection of light by mirrors. Similarly, we will talk about refraction of light by lens. So here we will first see what is a lens. So what is a lens? It is a transparent optical medium bounded by two surfaces, at least one being spherical. So that means it is an optical medium, transparent, which has two surfaces. Now, one of the surfaces has to be a spherical surface. That means there are different types of lenses that can be formed. You can have one spherical surface, one plane surface. You can have both spherical surfaces. You can have both spherical surfaces in this way. You can have one spherical surface and another as well spherical surface. So there are different types of lenses that can be formed by different combination of spherical surfaces. However, we divide lens into two broad categories, that is simple lenses and compound lenses. Now what are simple lenses? Under simple lenses you have all these different lenses which are formed by combination of one spherical surface and another spherical or plane surface. For example, this is formed by two convex surfaces, that is called a biconvex lens. This is formed by one plane and one convex, therefore called plano-convex. This is made up of one concave and one convex, so it is called positive meniscus or concavo-convex. Similarly, this is made up of two convex, so this is known as negative meniscus. This is made of one plane and one concave called plano-concave. That is made up of two concave and therefore called biconcave. So by combination of different spherical surfaces and plane surfaces, we get these different types of simple lenses. And what are compound lenses? They are nothing but combination of simple lenses. That means two or more simple lenses when combined together form a compound lens. You generally see these compound lenses in the lenses used in cameras or video recorders. So in things like that you have compound lenses. That is an arrangement of combination of simple lenses. Now in this lesson we will focus on biconvex and biconcave lenses. So we will not talk about other types of lenses. We will only talk about biconvex and biconcave lenses. You'll learn about those other kinds of lenses and you'll learn about these lenses in more detail in your class 12. So let us try to understand the terminologies related to lenses like how we did for spherical mirrors. So since now you have got an idea of the spherical mirror, it will be easier for you to understand the concept in case of lens. So first we will talk about the optical center in a lens. What is the optical center? Optical center is the center of this lens. Now here we have taken the example of a convex lens. Now biconvex lens is often referred to as a convex lens. That means both the surfaces are convex. Similarly, biconcave lens is often known as concave lens. So throughout the lesson we will be talking about convex lens and concave lens. So when I talk about optical center, it is denoted by a capital O and it is the center of this lens. So this point is known as optical center. So it is similar to what we called as pole in case of a spherical mirror. So this is analogous to pole. Next is the principal axis. Here also principal axis is the same line which joins this optical center with the radius of curvature. Now here what would be the radius of curvature? This spherical lens is a part of a sphere. Similarly, this spherical lens is a part of a sphere. So both the spheres will have two radii of curvature. Now those points will be joined to the optical center through a line and that line is known as the principal axis. So here this is my principal axis. Next is the center of curvature. So again the same thing. It is a part of a sphere, and the center of that sphere is known as the center of curvature. So this spherical surface will have one center of curvature. Again, this spherical surface will have another center of curvature. So there will be two center of curvature involved here. Radius of curvature, again here we will have two radii of curvature. One radius will be the radius of this sphere, and another radius will be the radius of this sphere, right? So here radius of curvature is denoted by R1 and R2. Similarly, center of curvature is denoted by C1 and C2, because we have two centers of curvature, two radii of curvature. That is why we have denotions for two. Next is principal focus. So what is principal focus in case of a convex lens? Now here in convex lens we see that when rays of light parallel to the principal axis falls on this lens, after passing through the lens they bend as expected, right? That is because it suffers refraction. It enters from a rarer to denser, again from denser to rarer. So as a result of refraction, it is seen that the rays of light appear to converge at a point. Now this point, as per definition of principal focus, what was the definition of principal focus? It was the point where the rays of light parallel to principal axis after reflection should converge or appear to converge. So in this case we see that in case of a convex lens, the rays actually converge at a point, and this point is known as the principal focus of this lens. Now in case of concave lens, what do we see? This is a concave lens. We see that the rays of light after passing through the concave lens, they diverge out. They do not appear to converge at a point. However, they are extrapolated at the back and they are virtually made to converge at a point. So this point is known as the principal focus for a concave lens, right? So in this case, one interesting thing which we note here is, here convex lens is the converging lens, right? Because here the rays of light actually converge after refraction, whereas a concave lens is a diverging lens, because the rays of light appear to diverge after refraction. So this is just the opposite as was in case of mirror. In case of mirror, a concave mirror was a converging mirror, but in lens, a convex lens is a converging lens. So please remember this, do not get confused. A concave mirror is always a converging mirror, and a convex lens is always a converging lens. See, as I'll give you a personal suggestion here, that when you go through this lesson, first understand the mirror part very clearly. So once you understand the mirror part very clearly, only then start studying lenses. Otherwise you might get confused, because if you study the entire lesson, just at one go, sometimes what happens is people get confused that which mirror is converging, which lens is diverging. So they get very much confused. So it is better that first you become thorough with your spherical mirrors, only then you start studying lenses. That will make things better, right? So what do we see here? So here we spoke about optical center, centers of curvature, radii of curvature, principal axis and principal focus. So now we will study the image formation by spherical lenses. Similar to spherical mirrors, there are certain rules that has to be followed for image formation by spherical lens as well. So let us quickly look at the rules. So here comes the first rule. It says that a ray of light incident on the lens parallel to the principal axis after refraction passes through the second principal focus. Now from where did we get the second principal focus? This is again another interesting thing. So let us again go back to the previous slide. So here if you see, since you have two spherical surfaces, it is like a combination of two spherical surfaces. So that is why you have two centers of curvature. That is why you have two radii of curvature. Now if you have two radii of curvature, that means you will have two principal focus as well, because this is, when you consider this convex lens, there are two convex surfaces. For this convex surface, you will have one focus. Again, for this convex surface, you will have another principal focus. So you will have two principal focus as well. That is why we call it as principal foci. So the focus of this surface, the focus which is on the left hand side, that is known as F1, right? And the focus which you see on the right hand side is known as F2. So this is my F2, that is also known as second principal focus, and the focus of this surface which lies somewhere on this side is known as F1, that is the first principal focus. So there are two principal focus, first principal focus and second principal focus, right? Now we will, at your level, as per your syllabus, we will not talk much about the two different radii of curvature R1 and R2 or F1 and F2. We will only look at a broader picture. We will just see the behavior of the lens when incident rays fall on it. You will know in more detail about first principal focus and second principal focus in your class 12. In case you are interested to know about it now, you can refer the videos of ray optics of class 12. Okay, so for now we will keep it here and we will see what happens in the first rule. So first rule says that, so just to remember, you remember it in this way, that first principal focus is the one which is on the left hand side of the lens, whether it is a concave lens or a convex lens, and second principal focus is the one which is on the right hand side of the lens, right? So a ray of light which is incident on the lens parallel to the principal axis, after refraction it passes through the second principal focus. So this is how it passes through in case of a convex lens. In case of a concave lens, it diverges. So if you try to extrapolate it, it appears to pass through the second principal focus. Now in this case, it is not passing through the second principal focus, instead it passes through the first principal focus. So this holds true only in case of a convex lens. In case of a concave lens, it appears to pass through F1. So in this case, appear to pass through F1, right? Now let us look at the next rule, rule number 2. It says a ray of light passing through first principal focus after refraction should move parallel to the principal axis. So if you see, these laws are exactly similar to the laws which we studied in case of spherical mirrors. Here the incident ray passes through the first principal focus, so after refraction it goes parallel to the principal axis. Similarly here, the ray of light falls on this mirror, it passes through this principal focus F2. If you see here, in convex and concave lens, your first and second principal focus gets reversed. In this case, if it passes through first principal focus, in this case it will appear to pass through the second principal focus, right? So after refraction it goes parallel to the principal axis, right? So here it appeared to pass through F2. And the third rule, which says that a ray of light passing through the optical center should go undeviated after refraction. So that means if a ray of light passes through the optical center, there should be no bending of light at all. So these are the three rules which basically governs the image formation in case of lenses. That means in lenses we have just three rules. One is it passes through optical center, goes undeviated, it goes parallel to principal axis, then after refraction it passes through focus. If it passes through focus, after refraction it goes parallel to the principal axis, right? So if you remember the picture of the lens, if you remember how the lens looks like and where is my first principal focus, where is my second principal focus, then you can easily plot the ray diagrams and there is no need to memorize the rules. If you understand them, there is no need to memorize. Now keeping these rules in mind, we will again go ahead and we will try to see the image formation by convex lenses and concave lenses separately for different object distances, like how we did for spherical mirrors. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.